Here we have a triangle ABC with angle A of 15 degrees and angle B of 30 degrees. We also have CD, which is a bisector of a side AB. That means it splits that side into two equal halves. And we are asked to find this angle X, which is angle CDB. So the way we're going to proceed is we're going to draw a circle around this triangle. And before I go any further, I would like to discuss something about the circles and the angles. There's something called inscribed angle theorem. So if you look at this black angle BAC, so the vertex of this angle sits on a circle, and two sides of this angle cross the circle at points B and C. Now what we're doing here is we creating a red angle that also goes through points B and C, but the vertex of this angle is the center of a circle, point O. So this angle BOC is called a central angle, and angle BAC is called inscribed angle. And what we need to know here is that the central angle is twice as large as inscribed angle. Okay? And this is what's written here. So the measure of angle BOC is twice the measure of angle BAC. Now notice that this point A could be here, could be here, could be here, could be here, or could be here. And regardless where this point A is, the angle BAC will be half of the angle BOC. So let's proceed. So we get the center of the circle O, and we connect this O with the points A, C, and B that lay on that circle. So this AO, CO, and BO are all radii, right? So let's look at the angle CBA, this one, 30 degrees. This is an inscribed angle. And there is a central angle that corresponds to it, and this is AOC. So a central angle should be double the inscribed angle. So AOC should be 60 degrees. Okay. In a similar way, if you look at the inscribed angle CAB, which is 15 degrees, there is an angle COB, which is central angle that corresponds to it, and that angle will be obviously 30 degrees. Okay. And now let's look at this angle 60 degrees and 30 degrees together. They give us a 90-degree angle here. So angle AOB is 90 degrees. The next thing we notice that, as I said before, that AO, BO, and CO have the same length because they're all radii. Right? What we want to do now is to look at the segment OD. Okay? Notice this is the bisector of the side AB of the triangle AOB. Triangle AOB is an isosceles triangle since AO equals OB. And as such, this bisector OD, bisector of the side, will be also in the altitude of this triangle. It means that OD is at 90 degrees to AB. And also OD is going to be bisector of the angle O, which means it's going to split this angle into two equal parts. Whole angle is 90 degrees. Each part is 45. Okay? Part AOD is 45 and BOD is also 45. But now let's look at triangle ADO. This is a right triangle. Angle D is 90 degrees. Now the angle is 45 degrees. That means that the third angle we have here is also 45 degrees. This angle DAO. But now we got ourselves a triangle ADO that has two congruent angles. Such triangle is isosceles, which means that AD and DO have the same length. The next thing we want to do is we want to look at the big triangle ACO. Okay? What do we see here? We know that the angle AOC, this angle O for this triangle, is 60 degrees. We found it earlier. We also see this angle A is 60 degrees, 45 plus 15. But that means that the third angle C, right here, ACO, is also 60 degrees. So we have a triangle 60, 60, 60 degrees, and such a triangle is equilateral, which means that AC is also equal to AO and CO. Okay? Now, let's get rid of the circle now, because the circle, we don't need it anymore. And look what we have here. And what we want to pay attention is two triangles. Triangle ACD, that blue triangle, and triangle OCD, the green triangle. Okay? So what we notice about these triangles is that the side AD equals to the side OD. We also notice that the side AC, the red one, is the same length as side OC. And the last thing we notice, the side CD is shared by them, so obviously it's congruent to itself. Okay? But what we got here is two triangles that have three congruent sides. Such triangles are congruent. And since this triangles, the bluish one and greenish one, are congruent, it means that all the angles, corresponding or respective angles, are congruent. The angles we're interested in is those angles D. So ADC and ODC. Okay? They're congruent. But now notice if you add these two angles and add this additional angle ADO, which is 90 degrees, you get a full circle. You get 360 degrees. But that means that angle ODC, one of those green angles, should be 135 degrees. And now let's look at this angle more carefully. We find that this angle of 135 degrees consists of our angle X we're looking for right now, and an angle of 90 degrees, which means that angle X is 135 minus 90, which is 45 degrees.